Systems of Nonlinear Equations, Part 1. Solve the following system by the substitution method. Here I have two equations. The first equation is a linear equation, and the second equation is a quadratic equation. So I'm going to use the substitution method, and the same steps apply for the substitution method. If you look at the second equation, I have y equals x squared minus 2. So I already have y in terms of x. So I'm going to take the expression for y and put it into the first equation and solve for x. So when I substitute y equals x squared minus 2 into the first equation, I get x plus x squared minus 2 equals 4. Now this is a quadratic equation. It's in the form ax squared plus bx plus c. So I'm going to set this equation equal to 0 in order to solve for x. First, I'm going to rewrite the left side so that my x squared term is first. So I have x squared plus x minus 2 equals 4. Now I'll subtract 4 on both sides to let the right side equal 0. And I have x squared plus x minus 6 equals 0. Now I want to solve this equation, and I'm going to factor this and use the principle of zeros. So I'll factor this into two binomials. I have x times x in the first position of each parenthesis, and then I'm going to look at the constant term, which is a 6, and my factors of 6 are 1 times 6 and 2 times 3, and I want to choose the pair that when combined will give me a positive 1 in my middle term. So if I choose the 2 and the 3, I can have a positive 3 and a minus 2, and that will give me the positive 1 as my middle term. And you can check this out by FOILing or multiplying the two binomials together to make sure that you get the original quadratic. So now that we factored the quadratic, I can set each factor equal to 0 and solve for x. I have x plus 3 equals 0, so I'll subtract 3 from both sides, and I get x equals negative 3. And then I'll add 2 for my second factor, and I get x equals 2. So I have two solutions for x. X equals negative 3 and x equals 2. That means I'm going to have two solutions for y, and consequently two ordered pairs as a solution to my system. So I found x equals negative 3, and I'm going to take that value and plug it into my first equation to solve for y. So I have negative 3 plus y equals 4. I'll add 3 to both sides, and I get y equals 7. So that means when x is negative 3, y equals 7. So the first solution to the system is negative 3, 7. Now I'm going to plug in x equals 2 into the first equation and solve for y. So I have 2 plus y equals 4. I'll subtract 2 from both sides, and we get y equals 2. So whenever I plugged in a 2 for x, I got a 2 for y. So my second ordered pair solution is 2, 2. So the solution to the entire system of equations is negative 3, 7, and 2, 2.